welcome back. Santi is again with us, and today he will be presenting attacking Amazon Web Services from initial access to hardcore persistence.
Hello, how are you doing? Thank you for being here. No, it's okay. We have time. Again, I'm really glad to be here. Thank you. Now, I don't know if you were in yesterday's session. I talked about a really specific technique. The idea of this is going through some theory, some basic stuff, and going from what we can do to reach that point that we need to do the anti-forensics part. So the main idea is to be like a big demo where we implement a lot of attacks and we can see how a defender can see those logs, if the Gardut is going to detect us, and how can we do to bypass those and to lower our fingerprint when attacking AWS. Just a quick scanning of what you know. How many of you know about AWS or work with AWS? Please raise your hands. Okay, great. How many of you consider yourself a senior security engineer with AWS? Okay. So from what I understand, most of you understand what is AWS, but you are starting to work with this, right? Right or not? Okay, perfect. Well, again, I'm Santi, I'm from Argentina. I don't know if you know what this is. This is mate. This is the mate that you drink with your club mate, but how we drink back home. Let's start with some fundamentals of AWS so we are all in the same page, right? This is a diagram from the Cloud Security Alliance, and I like this diagram because it sets in one picture everything that we need to know about the cloud. Regarding the slides, I can share that with you. I would post them on LinkedIn after the presentation, and also I think this is going to be recorded. So if not, just ask me and I can share whatever you want of the material with you. The most important thing that I want you to understand from this slide is like everything is cloud right now. We are used to think about cloud with like AWS, Azure, but nowadays we are using a lot of services that are also cloud environments, and we are sharing with those environments data, and we need to take these considerations that we're going to see today to every third-party SaaS providers that we are integrating in our environment. Like most of the time when I do an assessment, it's like, no, we have everything in AWS, whatever, and they are using a Mongo Atlas tenant for their databases. And they are not considering that as a cloud environment because devs didn't tell security that the Mongo Atlas was a thing. So we need to try to be aware of every SaaS provider that we are using within our environment. That's why it's important to do asset discovery, asset management, that we engineers don't like that much. But yeah, it can allow us to reduce our headaches, especially because most SaaS providers now have a lot of connections, default connections with cloud provider. So they allow developers or engineers to integrate a SaaS with AWS with a one-click integration, and most of the time that one-click integration is not secure. And we can leverage that one-click integration to exploit them and to move laterally from a Mongo Atlas to AWS, and from AWS to do whatever we want to do. The other theory part that for me is super important is the shared responsibility model, because the shared responsibility model says what do we need to do in a security related stuff with our cloud provider and what's responsibility of AWS. But the thing is, like, if AWS doesn't execute security properly, or they are not covering what you need to cover in that specific area, you are the one that's going to be responsible if you are compromised. One example is when you are running code in a Lambda function. A Lambda function allows you to run code without having servers, and the responsibility of the server and the networking and the physical security of the data centers is from AWS. But if I run a malware in a Lambda function without you knowing, you cannot install an antivirus or a EDR in a Lambda function. That should be AWS responsibility, but as we are going to see today, they are not monitoring that. So if we are able as attackers to leverage the shared responsibility model to understand what blind spots the defender have, we can lower our fingerprint and reduce the defender expectations working with the full sense of security. AWS does a lot of promotion of Guard-Duty as their one tool to detect all, and all the attacks that we are going to do today are going to be leveraged with Guard-Duty on, with full protections, and with a Discord channel notifying us when we are detected. For you to get an understanding what attacks the Guard-Duty is going to detect and what not, and what can we do to make him feel a little bit like noisy, right? The shared responsibility model is important when we move from infrastructure to software as a service. As I told you, infrastructure as a service is like an EC2 instance. I can do more stuff as an attacker in an EC2 instance, but also the defenders, because the blue team can install an EDR in an EC2 instance. What they cannot do is install an EDR in a Lambda function. And it happens the same with databases. For example, if you're running a database in an EC2 instance, you can install an EDR there. But if you are using RDS, that is the MySQL version of AWS, you cannot install anything there. So if I got access to a IAM level to the database, I can reset the password, for example, without anyone knowing if they are not monitoring CloudTrail and Guard-Duty. So we are like, the capabilities that we have as defenders are like not as much when you narrow them down, and we need to be aware of that. The other important thing is how the AWS tenants are segmented, and specifically the regionality of the services. The AWS offers like 15 different regions, and each region is like a different tenant. So I can create resources in whatever region I want, and the best practice is like if you have all the regions enabled, you should implement our security controls in every region. What most companies does is like to disable the regions that you are not using. You can do that at an organizational level. But if you only enable like North Virginia and Brazil, I can still use the non-enabled endpoints to make API calls that are not going to be detected. We're going to do a demo like that. How does it work? Basically, the endpoint is disabled, but it's not disabled. It's like, it is, but it's not. So if I got to execute an API call against a global endpoint, like S3 or IAM, that API call is going to be routed to the default region in my CLI. So if I'm specific targeting a region that is not enabled, that API call is going to be a success. It's going to retrieve the same information, but it's going to be logged in the non-enabled API call, in the non-enabled region. So as it's not enabled, the defender cannot implement security controls because you cannot deploy infrastructure on that. And the log is going to be like in a /dev/null. So we can take advantage of those techniques to do enumeration without being like detected or being even monitored by the defenders, right? The same happens with every kind of resources. AWS has like 250 resources. We can play like this. I'm only giving you some examples. This is like an 8-hour training that I'm wrapping up in 1 hour. So, but imagine that you can do the same kind of attacks to machine learning models, to data science, to like ChatGPTs from AWS. So at the end of the day, I think the most important thing that we need to understand when we are attacking AWS is like taking account of the regionality of the services, the shared responsibility model, and how to evade CloudTrail and Guard-Duty. If we can focus ourselves in those 3 key takeovers, we can do disasters with every different APIs of the different services, especially knowing that every service in AWS is managed for a different team. So not every service is hardened in the same way. And not all the default securities are the same for every service. For example, talking about databases, if you deploy a Redis server in AWS, by default the communications are in plain text and without password. So if the developer clicked next, Redis server, it's going to be in plain text and without password. If they are launching an MSK server, it happens the same. And we can jump into the software development lifecycle supply chain to do a lot of stuff, right? But again, we need I don't have enough time, but if you want to talk about a specific service or a specific consideration that in your company are having, reach me out. I'm going to be here all day. Regarding networking, the difficulty for security teams in networking is it's not like a traditional firewall, or if you are working with GCP or Azure, that you have I'm blocking this IP, I'm allowing this IP. You have a security group that is a service that only allows traffic. So if you have those two resources that want to talk with each other, you can implement a security group. But you cannot deny. So what most defenders do when they are trying to contain an incident is they try to remove the security group. But you cannot remove the security group because every resource must have at least one security group. So they end up fighting with this process of, okay, I need to create a new security group to change it from the other one, and for them it takes a lot of time, especially if they haven't trained in the incident response processes. The good practice is to have a forensic security group ready for you to deploy. But again, security groups are VPC constraints. And you can have multiple VPCs in each region, and you can have multiple regions in each account. So for the defenders, they need to have a lot of infrastructure deployed just because in each account and in each region, and they need to know how to administrate that. So if we are detected, the defenders need to be able to understand where we are. And if we are able to jump from one region to the other, jump from one account to the other using trusted entities or different components that we are going to see in the demos, for them it's going to be super difficult to track and to trace, especially because, again, as we saw yesterday, and if you didn't see it, I am going to repeat today, CloudTrail is slow. We have 15 minutes of delay from the log to be generated into it, and it arrives to the SIEM. So if they are trying to monitor us with that 15 minutes of delay, we are way ahead on what we are doing. Especially that then you need to add the operational delays of the SOC team to respond to that incident if they understand what is the severity of the issue. Again, if they are following our duty, most of the time they are going to analyze that as a false positive or as a low severity incident, right? Okay, let's talk about a little bit of security operations. Again, this is the slide that for me is super important to understand what are the delays that we have from the guard duty on CloudTrail event is generated and it arrives to our SIEM. I'm not going to explain this in detail, but basically, from a defender's perspective, we have these constraints that buses and data transmission buses in AWS are weird. So you have 3 different buses in which you can ship logs to the SIEM. The fastest one is Event Bridge that triggers events in an immediately. It's if I execute an API call now, it's going to be in the bus 20 seconds from when I execute the API call. But you cannot implement a SIEM with that because the bus is so big that it will overflow the SIEM. So it always breaks the integration, and also it's a really expensive bus because you need to have a Lambda function that is pushing the information to the SIEM, and it's going to trigger each time that the bus is receiving an API call, and you can have thousands of API calls per second. So it's not feasible. The second fastest bus is CloudWatch, as you can see here. CloudWatch has a 5 minutes of delay, and it allows you to batch the buses that you are shipping the information that you are shipping to the SIEM. But most SIEMs doesn't accept integration with CloudWatch because, again, you need a Lambda function in your AWS tenant to ship those logs to the SIEM. And again, if you have 100 accounts, you need 100 Lambda functions, and you need one Lambda function per account and one Lambda function per region most of the time, because CloudWatch is a regional service. So if I'm using 5 regions per 100 accounts, I need to maintain 100 Lambda functions, and that's also not feasible. That's why most of the SIEMs use this integration, and it's like the S3 bucket one that has like 15 minutes of delay, so it's crap, but you can maintain only one Lambda function per account. So it allows you to monitor in a more like maintained way, right? And you can also batch the events that are arriving to the S3 bucket, and you can like format those as you want, and SIEMs have like more maturity receiving these kinds of events. But then SIEMs split in two. There you have like Datadog, Panther, that are like the most sophisticated SIEMs, allows you to deploy a forwarder in your account that is going to be triggering whatever the event arrives to the S3 bucket, and you are going to get a notification almost immediately after the 15 minutes delay. But older SIEMs like Splunk or QRadar or even Wasu are pulling the events from the S3 bucket. So once per 5, 10, 8, 3, whatever minutes, they are pulling the events from the bucket, and they are processing them when they are pulled. So if you have 15 minutes of delay plus the 10 minutes pull, you can have like 25 minutes of delay. And also they are charging you for that processing time. So they encourage you to make that delay larger so you pay less money. So at the end of the day, it's like super hard for us to be monitoring CloudTrail logs. And CloudTrail is not the only log. This is like the full list of logs that you can implement in AWS. So there is a log for everything, and again, as every service is maintained for different teams, they don't put they didn't agree on what log format they should use. So for example, VPC flow logs is a text string with space separated columns that you can set, and load balancer logs is a JSON, is a CSV, and CloudTrail is a JSON. So every log has its own format, and you need to guess, or you need to create a specific parser for each one of those, and that can be like super tricky from the defenders. Also, as there are not so much maturity in the SIEMs, they don't provide you with an out-of-the-box normalizer and parser, so you need to do that on your own, and it takes a lot of time. The idea is not for you to read the text. If you want the spreadsheet, they can share that with you, but the idea is like, whenever you are implementing security in AWS, take into consideration that most logs you need to enable those on your own, and you need to create the integrations to ship those logs. Even though the same principle that I told you here applies. So the only 3 ways to store logs and to ship to the SIEM is like by Event Bridge, by CloudWatch, or using S3, right? So no matter what logs we are enabled, we are going to be fighting with those, with these considerations. And here you have 2 examples. In the left, we have a CloudTrail log that we're going to be in detail more in the demos. CloudTrail is JSON, right? It's super verbose. We can see a lot of information. As defenders, we can see source IP, user agent. We can have like even the error log. So for us, it's super verbose. In an incident response, it's like the bread and butter that I can use to do forensics in AWS. GuardDuty, again, is like it's more beautiful, and it's also a JSON event, but they ship to you the information that Amazon thinks is important for you. And you, as a defender, cannot create new detection rules. So if you are, as a defender, trusting in GuardDuty, you are trusting on what AWS understand that is important for you to monitor, without knowing your context, without knowing what are your critical applications, what are your critical servers, what are your critical S3 buckets. So again, it's nice to have, but it's not perfect at all, and we don't need to believe that it's perfect at all, and there is a lot of marketing to let us know that it's perfect, right? Okay, let's go with the demos. How much time do you have? Great, I have 40 minutes. Okay, do you see my terminal? Where do you think that most AWS attacks start? Somebody? Sorry?
Developer credentials?
Open credentials, right, yes. Every AWS attack starts, or most of them start from getting credentials, right? Getting a credential, I think whenever I talk about red teaming or pen testing in AWS, getting to the credential for me is like part of the traditional part of the pen test. Most of the engagement starts like, oh, I drop a phishing into a DevOps workstation and I got credentials in the DevOps workstation. Or I landed with an XSS in a server and the server has access to AWS. So for this example, I'm going to show you where to get credentials in different places, right? Let's box it like initial access / lateral movement, let's say. So if you land in a workstation, like for the method that you like, doing whatever stuff you like, I'm not going to judge you, you can always look for one specific folder where the credential is stored. You can have like .aws. In this folder, you have like two kinds of credentials. You have static credentials and dynamic credentials. Why is that? You can use the secure way of using credentials in AWS is using roles. Roles has access keys, secret access keys, and a session token. The session token expires, so AWS recommends you to use roles for everything you want to do. But the difficulty with that is like they are hard to implement if you are not always in the AWS environment. So whenever you need to implement something that is not going to be run in AWS, the logic that you need to implement in code for you to use the role is most of the time more complex than the code that you are running. So most of the time, people what they do is that they use IAM users. The IAM users doesn't have a session token. So if I got access to a to an IAM user credential that works, it's going to work forever or until it's disabled. So it's super dangerous, and if we are, as a defender, if we are agreed to use an IAM user, we should be aware that we need to implement heavy monitoring to that user, and we need to implement least privilege to that user, so they don't have access to our whole AWS tenant. The nice part of the IAM user is like it's restricted to the account. So if I have 100 accounts and I got access to one IAM user, that IAM user is only going to be able to execute things in that account. So inside the .aws folder, I have like several files. The most important one is this that says credentials. If I cut credentials, as you can see here, you are going to see a role that's called a profile that's called backdoor, and an access key and a secret access key, right? We have Lambda, that is an access key and a secret access key, and I have a BD role. How do you notice that this is a BD role? Because this has this beautiful session token. So if I execute an API call, let's say AWS S3LS profile BD role, this should fail. Again, live demo. So if the god of demo they are not with me today, it's not my fault. As you can see, I have the expired token error. For us as defenders, we need to be monitoring this kind of error because it's somebody proving our credentials, right? So if they get the expired token, I can get that in CloudTrail, right? As a defender, we're going to see that in a few moments. But if I, instead of using BD role, I use the backdoor role that was an IAM user, I'm going to see the whole list of S3 buckets that are in my account. S3 is a is a global endpoint. As I was telling you, I can execute back the S3LS, and this is going to be forward to US is 1 because it's the default region in my profile. But if I target region US is 2, this is going to output the same result, but the log is going to be forward to US is 2. If I go to my account and I try to go to the region US is 2, that's Ohio, you're going to see that everything is disabled because I have the good practice and I have like this hardening strategy of not allowing this region. As you can see, I cannot see anything. I'm administrator in the region, but if I would like to go to CloudTrail, if I go to CloudTrail, you are going to see that I don't have access to see CloudTrail, right? So this event is going to be recorded in a region that is not enabled. How can I test that? The trick that we can use as a defenders to bypass this disable restriction that AWS does is like I can go again to Virginia and I can look for CloudTrail in here. There is this tab that is event history that is recording constantly whatever I'm doing. So event history is a way that defenders can access CloudTrail logs immediately in a GUI way. And this is not possible to disable and it's always enabled. And if I from event history in Virginia, I move to Ohio, even though it's disabled, even though I cannot implement anything, I can see the records that are being registered in Ohio. As you can see here, I have a couple of console login also. Again, if I got to get access to the console of AWS and I log into the console in AWS from a global endpoint as is I am, but I'm into Ohio, that API call is not going to be recorded in Virginia, it's going to be recorded in Ohio. As you can see here, in the whole life of my account, it only has 3 API calls. So it's important for us to be aware of those things. I can, in event history, I can search for a specific activity of my credential, like based on the access key. This is super useful for triage when the defender has not prepared itself. And as you can see here, we have the list bucket from the 21. This is the list bucket that I just executed. So even though CloudTrail 2S3 has 15 minutes of delay, event history is immediate. Why? Because it's using event bridge. So if you are defending and you need to be aware of something that's happening now, event history is your best tool because it cannot be disabled. Were you able to follow me with this example? Great. If we go here to the list bucket API call, we are going to see the IP. We have a great wrap up. But we can look things like the user agent. If we go to see the user agent, we know that I'm using an AWS CLI. Other things that the defenders are monitoring. If you are using that API key with a Python script has a specific user agent that is Boto3. So what we can do as defenders is to create a specific detention rules for access keys that are being used for different user agents. And if the attacker is not crafting the user agent, we can detect the misbehavior, right? But what can we do from with the access key? Well, we can have different paths. The first thing that we should do, or we would try to do, is like to understand from a black box perspective which user this is. So I can execute this command that is sts get caller identity profile backdoor. Get even. So this command will tell me, it's like a who am I from AWS. As you can say, it says you are an IAM user that's called ransom and you are in this account. So with this I can know where I'm working. It's hard to apply this command in productive environments because it's one of the API calls that are heavily monitored by CMs. It's like they are looking for the STS get caller identity. So unless you know that they are not monitoring this API call, I should encourage you to don't do this. And there are other ways that you can find what's your ARN, like using like list users or different API calls, right? But let's say that we want to exploit this layer of how AWS works, that you have like this logical level on how resources are managed. So I can check if the IAM user has console access to log in myself in a GUI interface to do like more like specific stuff. So I can execute the command like it's like AWS IAM, another global endpoint, that's get login profile. I need to pass the username, that's ransom, and the profile backdoor. What this is going to tell me is like if the IAM user that I got credentials from has console access. As you can see, it returns at 200, so it has console access, and it's not required password reset. So what I can do, as an attacker perspective, is like I don't know the password, but I don't have to know the password because the logical IAM privilege allows me to work with environments like this, no matter what the infrastructure layer is. And this example is the same for servers, databases, for whatever service that you want to reset a password. You can basically delete the login profile and then I'm going to execute a get login profile again to see how the error looks like when you don't have a login profile. You know it's like not such entity exception, and I can now execute a create login profile. I'm going to pass the user and the new password. That's BalCCon. So now I have reset the IAM user credentials. So I can log in to the console with the new credentials without having known previously what was the credential before. It didn't ask me for the credential before. So I can use AWS Management Console. And I can go and say sign in. And as you can see here, it's going to ask me for data. It's going to ask me for the account ID. So I can go to STS get core identity and grab the account ID. Okay. I know that the user is ransom and the password is BalCCon2k25. And I have access to the console, right? So as the user used to have access to the console, they are not monitoring requests with the user agent, Firefox, Chrome, whatever. So I can now move laterally with the user that I have compromised if the demo works and the internet connection allows me. I trust you. Please don't fail. Please don't fail. Well, maybe it's... There it is. So as you can see, I'm the ransom user, and I'm in the AWS console already. Why would an attacker would like to get access to the AWS console? Maybe because they don't know how to execute API calls with the CLI. Maybe because they are more comfortable. We don't, most of the time, attackers don't know all the infrastructure that they are compromising, and they want to be more like familiar with what they are using. It's not common also to be able to like execute API calls for everything that you need to do. For example, if I would like to do a lateral movement from here and I would like to retrieve credentials from other places, where do you think that credentials live within an AWS environment? Where we have, for example, Lambda functions. A lot of misconceptions when a developer is implementing something in AWS is like they use the default best practices that were using in their traditional on-prem environments. So they are really using environment variables. In a server, an environment variables is kind of isolated because nobody has access to the server or nobody should. But in AWS, whoever has least access to the Lambda function or the ECS server or the Kubernetes server, they can see the environment variables. So if I have something like this in the Lambda function, I'm going to move to Brazil. And if I have like the Lambda function with default credentials enabled, I would able to retrieve all the secrets that exist in the Lambda function. No, it's not here, it's in Virginia. Conference demo. If I go to configuration and I go to environment variables, I can see access key and secret access key. This maybe looks like super easy, but you would surprise the amount of people that is doing this because, again, they move to AWS and they don't know that much how to work with that. But if we analyze something like the Datadog forwarder Lambda, that is like a built-in appliance that they are telling you to use, they also are using environment variables like this, right? So I can work with data from environment variables like in different ways. And I can move from here and to retrieve credentials from, once in assessment I got like, I retrieved security credentials from an environment variable in an Elastic Container Service. I proved that with STS get query identity and were the root credentials of the account. So if you are rooting the account, you can do whatever you want, especially if like they are using that in that way. So again, good practices are always like the most important thing that we should do. But if I would try to do that from the console, it's harder to process, but also it's easier to automate. In the same way, I could list like all the functions in AWS, and this is going to retrieve to me like a beautiful JSON file. But I can grab like access. I can look for the access keys in the environment variables. I can do something like this, and I can do the same from the CLI, right? So I could easily write a script that executes the list functions and retrieve every credential like that start with a pattern, like AKEI is how credentials start for IAM users, and ASA is how the credentials start from IAM roles, right? So I didn't show you, but we have Garduti enabled here. I don't have notifications yet, but if I go here, this is Ohio, but if I go to the compromised user, I can see that there is a Garduti setting enabled, and it's monitoring everything that we are doing. So all the lateral movements that we already did, or the escalation of privileges, has not been detected by Garduti yet. So again, it's not a silver bullet, okay? So what else I can do from the console? I could try to retrieve information from servers. Again, this is like every system. Most of the time, they implement a lot of features for convenience of the user that they don't even understand what is the risk behind them. But the extra difficulty with AWS when you're trying to harden is that they are so keen to tag things as vulnerabilities, because most of the time they say it's a misconfiguration, What's a misconfiguration? This says, no, because if the user have hardened their account correctly, that wouldn't happen. And this is one example of that. I have a server here that is a Linux server that is running in AWS. In order for you to SSH a server in AWS, you need a private key. If you don't have the private key, you shouldn't have access to the server. That's why, and that's how they sell to you. And that's why most companies, or a lot of companies, what they do is like they expose the SSH to internet because they say, if I don't have the private key, I couldn't connect to the server. And it's something that I see a lot, especially in Latin America. But AWS adds a feature that's called Instance Connect that allows me to connect to the server from the web browser without having the SSH credentials. So I can connect to the server without asking for credentials, only having permissions with the IAM user. So again, that boundary from infrastructure and permissions, as I was able to reset a credential of a user, allows me to have access to the box. Servers in AWS are not hardened by default because of the shared responsibility model. So as they are not hardened by default, I can do whatever I want in this SSH box, like for example cat.ssh authorized keys, and I could add my SSH authorized keys to this file, and I could use my private key. As you can see here, this server has already been compromised because you have two public keys in here. But if you go to the server and look for key, here you have key pair. I know it's small, but trust me, you have key pair assign. There is no key pair. So if you are using a tool like a cloud security posture management to enumerate your cloud and to understand if you have servers that are compromised, as the shared responsibility model stops in the management console and not in the server, they are not telling you what's going on. If you haven't implemented an EDR in the server, you are not being able to monitor what's going on here. I could also run a ransomware in here, a cryptocurrency miner, and that's not part of the AWS problem. And they tell you so. It's whatever happens in your server is your server. If the server has malicious activity, they can also block your account. It's they are not going to prevent it. They are going to say, okay, you are using malicious stuff, I'm blocking your account. And they can compromise your whole business with that, right? So again, I have done SSH to a server. I don't have Carduty findings. It's the defense that you are able to apply from Carduty is not that much. But what else I can do? For example, I like sitting here in the server because it's this is another example of how you can get initial access, because maybe you land in the server with an exploit, or maybe they were running a public web interface with this server and you were able to have a console access or a shell to this server. So what can you do? You can work with something that's called instance metadata. Instance metadata is a feature that the server have that allows you to retrieve information that the server of the server, like the server public IP, the server IAM role. It's used for developers to fasten the development experience. There are two versions of metadata, the version 1 and the version 2. The version 2 is more secure because it requires you to have a session token, but most of the time that session token needs to live anywhere, needs to live somewhere. So if you land in a server that is running a script that is interacting with the metadata, the session token can be there. So it can be in the environment variables, or it can be in hard code in the script, or the session token needs to be, and you need to find that, but it's more like a traditional pen testing stuff. But what you can do here is you can curl to that IP. This IP is always the same IP, and it's always the same for multiple cloud providers. So if you land in an OCI box, you can do the same metadata search as if it were AWS. And you can go to this path that shows the credentials for the instance. And as you can see here, I'm getting the access key, the secret access key, and the session token from the server. So I can retrieve the credentials from the server, and I can use them to impersonate the server. And if I execute an API call here, like S3LS, and I pass the region US is 2, this API call is going to work. If I type it well, maybe it's better. Region. There it is. So the other problem with AWS is like everything is an IAM user at the same time. Servers, databases, Lambda functions, machine learning models, they all can have permissions. So if I am able to land in a server, not because it's a server, it means that it doesn't have access to AWS. So we can do the same. I can work from here and I execute an STS get caller identity, STS get caller identity, and it's going to say me, who are you, And the thing is like, the STS get caller identity, and this is what is hard to monitor when you are using an EC2 server, is because it says you are a role, but the role is attached to that entity. And the API call in CloudTrail is going to come like if it were from this user. So now you know that we are working with a role because I show you the full step, but I'm going to show you the view of the incident response team. If they come here and they want to look in event history and see the logs from this server, okay. Let's see in let's see all the logs from the last 2 months. Okay, now I am going to use username like this. Okay, we don't have logs yet. Let's try in Virginia. The thing is like the logs are going to come from the username related to the IAM entity. Let's try with the API key. As you can see, CloudTrail is not the fastest thing in the world, but I'm going to wait for the API call to land to event history because of the delays, and we can check for that later. But the thing is like, based on what we saw, is like if I'm able to work with a region that they are not monitoring, and it's like, and I got to apply the anti-forensic techniques that I showed you yesterday about like disabling RDuty, disabling CloudTrail, I could be able to launch a backdoor, and with that backdoor, I can execute API calls in AWS and get access from outside, right? For sake of time, I'm going to jump to the last demo for you to get an idea of the importance of the blind spot of the shared responsibility model. When I do the blue team training, what I do is like, hey guys, there is a ransomware in the tenant, look for it. And as AWS doesn't tell you that there is malware running in Lambda functions, there is no dynamic way to monitor for that. It's like, and you need to search in so many places. So what you can do as an attacker to execute a fancy persistence in a tenant, you can launch a stack that's called like API gateway with a Lambda function. Why I like to use that? Because the API gateway in AWS allows you, it gives you a secure endpoint. It gives you an endpoint with an AWS sign URL. So if I can have a AWS signed URL and I can run code from that triggering a Lambda function, I can execute those API calls from wherever I am. So if I land in your infrastructure and I have my backdoor pointing to AWS, your UTM, your content filtering is not going to be monitoring or blocking API calls or requests that are going to Amazon domains. So I can have something like this. This is a Lambda function it's an API with 2 endpoints. As if you go to the details of the Lambda of the API, you can see that there is this Amazon endpoint, Amazon.com, and behind this I have this Lambda function that is based in a Docker image. Why I like to use a Docker image for the Lambda function? Because it allows me to add an extra layer of deception. It's like, it's not good to use security as obscurity for security, but imagine that incident responders, they are not, we are not like heavy training cloud, and finding someone that is training cloud and also in Docker and also in pen testing, it's like super hard. Especially in a CTF that I like to do is like I give them an ARM container and they are trying to run that in Windows and it's going to break because you need to specify what's the architecture of the container, right? So those are simple tricks that are like steps of issues for the defenders. So, and also when you run a Lambda function that's based in a container, you cannot see the code. You need to get access to the ECR, you need to do a lot of stuff in order to get the code and reverse it. But basically, you can have an API endpoint. Let's close this. The API endpoint is the API gateway URL, and I can run code as if it were my CLI. I can run an STS get caller identity, for example, and I'm going to get like this 200 and whatever I'm doing, right? So if I get to disable order detection, again, Garduti is still our friend. We are not getting notification yet. Everything we did, Garduti didn't see anything. But we can do more stuff like here. We can create an IAM user, like IAM create user name BalCCon. It works well. We have the BalCCon user created. If I go to the IAM login page, we're going to see the IAM user created. Garduti is still our friend, you know? And we have the BalCCon user just created, right? And the nice trick is like the API calls, and I would try to see if like if the delays work in my favor this time. But if I'm looking for the create user, event name, create user, get caller identity. Okay, this is the get caller identity executed with the Lambda, right? As you can see, the username is the name of the Lambda. So if you get a get caller identity, you're going to say, who the fuck is this user? You go to the user tab and you don't see that user. So there is nothing that tells you that this came from a Lambda function. Also, if I try to investigate the log, it's going to come from a source IP that if I geolocate the IP, it's going to say, you are an Amazon Web Service, you know? So the API call is coming from a user that doesn't exist, that lives in an Amazon server in Brazil. So the output API call is not going to be blocked because you are not blocking Amazon. And most of the threat intelligence feeds, what they do is like they whitelist like Amazon GCP because of the noise that it generates. So you are able to execute API calls like from a more hidden perspective, exploiting this blind spot of the shared responsibility model. So if we put everything together, and for wrapping up, because I only have 5 minutes, it's like, we need to be aware of the shared responsibility model and to understand what, as defenders, we can do to understand those blind spots and to strict the security controls on those blind spots. And as attackers, we need to understand what the defenders can do to monitor us and how they are going to see us. We need to be aware of the delays to apply what we saw yesterday about the anti-forensics part. We need to take into consideration that most misconfigurations are there because of the defaults. Amazon is working a lot to restrict the defaults, but most defaults are not as secure as they should be. And especially because startups are keen to go to market fast. And as they are going to market fast, they do stuff as they can. And I don't know if everybody is fully aware of what are the risks of what can happen with this kind of access. And whenever somebody gets access to one credential and they move laterally, they can persist in your environment without you knowing. And it's super difficult to get a user out from your account because there is no hard reset in AWS. You cannot fresh install Windows Server and reproduce your domain. It's like, even though with tools like AWS Nuke that allows you to wipe your full account, there can still be things. And as I showed yesterday, for example, if I add a resource policy that doesn't allow you to modify me, even the root user cannot delete my user. So there are a lot of tricks that can be applied. So, well, sorry if it was like super fast. I tried to put everything I wanted to share with you. I don't know if I have time for questions, but if not, I'm going to be around and we can chat and go deeper with whatever you want. Thank you.
Hi, great talk. When you logged into the EC server via GUI, I've seen that there is no SSH keys for this web login. How do you see it on Linux side? So you can only see in Amazon Web GUI this login for event. What's the way to log in into the? Is it agent or something else?
Yeah, you're not going to, if you log in using the connection or whatever, it's a Linux box. So if you have syslog or you're monitoring SSH logs, you can see that, but you need to actively ship those to your SIEM or to wherever you want to go. Or if you are doing forensics, you can retrieve all artifacts like if it were, because it's a Linux box. But the important thing is like Amazon would not help you with that. So
I meant, what's the mechanism to get into the Linux? Is there like an Amazon agent in the Linux, or it's not using the SSH key to log in?
No. There is a way. No. This implementation use like it's like the service of ECS, and it's using the URIAM row. You can install an Amazon agent that opens another window of compromise, but it's like a third way of compromising. But you need to have like the agent installed, and you need to have access to the agent also. But yes, that's like a third way of connecting to the server.
Thanks.
Thank you for the question.
Any more questions?
Well, thank you for being here, and see you around.